Good morning students, welcome to our next lecture of data structures and algorithms. In our previous lecture, in our previous video, we have discussed about the tree's introduction. Tree, that is a non-linear data structure. We discussed about its introduction, that is what is the basic definition of a tree, the main terminologies, the main terms that we will be frequently using throughout our topic tree. So today we will study about binary tree. Our next topic in our tree non-linear data structure is binary tree. Binary tree is one of the most important concept of our main topic tree. So binary tree is a kind of tree that has at most two branches. That is, a tree is a binary tree if each node of it can have at most two branches. In a binary tree, now first let us understand what is the meaning of binary tree. Any tree, any kind of tree or a tree that we have is known as a binary tree if its each node has at most two branches. At most two branches means each node can either have no branch, one branch or two branches. But any node cannot have more than two branches. That's why we have written here at most two branches. At most means maximum of two branches. So any tree is known as a binary tree whose each node have at most two branches. At most two branches means any node can have either zero branch, that is no branch at all, no children. Second one is one branch, that is either left subtree or right subtree, and the third one is at most two branches, that means maximum of two branches. First one is left subtree and the second one is right subtree. Moving towards our next point, a binary tree T. We will be always representing our binary tree with capital T. A binary tree, capital T, is a finite set of nodes. A binary tree, now let's consider a binary tree. In that binary tree we have a finite set of nodes. Now from those finite set of nodes, what we will consider? Nodes which is either, now those nodes can be either empty tree or null tree. As we have discussed just now that any node in binary tree can have either zero branches or one branch or at most two branches. So the nodes of a binary tree can have either empty tree or null tree. Empty tree or null tree means any node who is not having any of the left subtree or right subtree is known as empty tree or null tree. Let's see this example, this tree. This is a tree. In this tree we have A as the root node. A as the root node, that is we discussed in our earlier video. The specially designed node is known as the root node. So here A is known as the root node of this whole tree. Now A has two children. Two children means B and C. That means two children can also be known as two subtrees. B is the left subtree and C is the right subtree. Here we have written this. B is the left child or left subtree. We can also call it a subtree, left child or left subtree. C is known as the right child or right subtree. Right subtree. We are calling them as left and right because A is our root node, B is present on the left side of A, that means we will see the left and right sides as our left and right sides. So while we are looking at this tree, so when we are looking at this tree, B comes on our left hand side and C comes on our right hand side. That's why we are taking B as left subtree of root A and C as right subtree of root A. So we will see left and right according to our left hand and right hand. That's why we are taking B as left subtree of root A and C as right subtree of root A. Second point is consists of special node called root node denoted by capital R. We have discussed this in our previous video that a specially designed node is always present at the topmost level of the tree, and that specially designed node is known as the root node of the tree. So here we are having A as the root node of our this given tree. And the third point states that two disjoint binary tree T1 and T2 according to the root. Now on considering this root node A, we are having two disjoint binary trees of root node. These two disjoint binary trees of root node are B and C. B is known as the left subtree of root A, C is known as the right subtree of root A, and we can denote these left subtree and right subtree with T1 and T2. So these T1 and T2 now become the disjoint binary trees of root node A. Similarly, on moving downwards our tree, while taking B as the next root node, D and E become their next disjoint binary trees as T3 and T4. Coming to C, as now taking C as root node, we will get F as next disjoint binary tree as T4, T5. After that, this will become T6, T7 is not present. We will take this as T7 and T8. So these will be our disjoint binary trees which we will be representing using T1, T2, T3 and so on. Okay. So these disjoint binary trees can be represented according to the roots, according to the root node. So A is the root node of this tree. On considering A as the root node, we are having two disjoint binary trees of A, B and C. These two disjoint binary trees further can be represented as root node for their subtrees. That's why we are taking in B as root node in our next level, so that we can represent subtrees of node B also. Okay, so in this way we can represent binary tree with that is having a finite set of nodes, and those finite set of nodes can be either empty tree or null tree. So empty tree or null tree means here we are having this node E. Now this node E does not have any subtree. Any subtree means no left subtree and no right subtree. So here node E or T4 disjoint binary tree T4 becomes our empty tree or null tree. We can consider node E as empty tree or null tree because it do not have any of the children or any of the left subtree or right subtree. That's why we are taking E as empty tree or null tree. Similarly, H and I also are empty tree or null trees. Now here B and C are siblings of each other. B and C are siblings of each other. We are taking it as sibling because sibling means children of one parent. So here A is the root node and A has two children B and C. That's why we are taking B and C as siblings and A as their parents. Similarly, on considering B as parent, D and E are the siblings and children of B. So the meaning of sibling denotes the children of same parent. Okay, so this was the basic introduction of binary tree. Now according to these properties, according to these points, we have drawn these four binary trees, these four types of trees, and we will check according to these points that among these four which one is a valid binary tree and which one is not, which one is an invalid binary tree. So according to these points, a binary tree, any tree is known as a binary tree whose each node can have at most two branches. Now we will first see this property that any node can have at most two branches. At most two branches means maximum of two branches. We can have one branch also and we cannot have any branch also, but we cannot have more than two branches. So first of all we will take this property. Now taking example A, here in this tree, look at this tree, we are having A as the root node. A root node is having two children B and C. Now our property gets fulfilled, B and C. On considering B as next root node, B does not have any children. That means B is empty tree or null tree. Considering C as next root node, C is also having two children. Yes, the property is getting fulfilled. Coming to D, D has also two children and E does not have any children. So this is a valid binary tree because each and every node is either having no children, one children, or at most two children. So this property, this main property of this first main property of binary tree is getting fulfilled. So we will write here as it is a valid binary tree. So this is a valid binary tree. Now taking second example B, in this example we are having a tree. Here A is the root node. A root node is having two children B and C. Yes, the property gets fulfilled. B is having one child. This property also gets fulfilled, and C is having no child at all. But here an edge is connecting root node to D, and this edge on connecting A to D will become a loop. This will become a loop or a cycle. So any of the graph, we consider any tree with no cycle as graph. So this becomes an invalid tree because here we encounter a loop or cycle which is not allowed in tree. Looking at the third example here we are having A as the root node having two children B and C. Our property of having at most two branches gets fulfilled. Coming downwards on considering B as next root node, B is also having two children D and E, C is also having two children F and G. But the extra edge that is connecting E to F, this is again making a cycle. This is again making a cycle which is not allowed in tree. So this also becomes an invalid binary tree. Now looking at the last example, in this example of tree we are having A as the root node, its two children B and C. B is having the left subtree, that is any node can have at most two branches, that means any node can have either 0 branch, 1 branch or 2 branches. So B is having 1 branch, C is having 2 branches, and no loop, no cycles are formed. So it will become a valid binary tree. So these 4 examples give us the main idea about what are the properties of a binary tree, or how we can classify any tree, whether it is a binary tree or not. So this was our today's introduction about binary tree. I hope you all have understood. Thank you very much.